All right, let's talk about one of the biggest technologies out there right now, large language models, or LLMs. You've definitely used them, maybe even every single day. But how do they actually work? What's really going on inside that black box? Well, let's dive in. So check this out. Just read this little story. It's got a beginning, a middle, an end. It's a coherent little narrative, right? Now here's the wild part. A computer wrote that. I mean, how is that even possible? It honestly feels like some kind of magic trick.
And that is the central question we're going to answer today. How does a machine, which is just a bunch of circuits and code, right, manage to do something so fundamentally human, like telling a story? We're going to pull back the curtain and show you exactly how the trick is done.
Okay, so here's the official textbook definition. A large language model, and that first word, large, is really the key. We're talking mind-bogglingly huge. These systems are trained on a massive chunk of the internet. Books, articles, Wikipedia, you name it. And they learn by adjusting billions of these things called parameters. The easiest way to think of parameters is like tiny little knobs that the AI is constantly tweaking to get better and better at finding patterns in all that language.
Now, if there's one single thing you take away from this entire explainer, please make it this. At its heart, an LLM is just a very, very sophisticated autocomplete. You know how your phone tries to guess the next word you're about to type? Well, imagine that on steroids. It's not just guessing the next word, it's predicting the next sentence, the next paragraph, the whole shebang. Okay, so this idea of a super autocomplete makes sense. But how does it actually work? Let's pop the hood and take a look. I promise you, it's less magic and more just really clever math. We're going to break it down step by step.
The entire journey, from the moment you type your question to the moment you get an answer, really boils down to these 4 key stages. Let's walk through each one.
First up, step 1, training data. You got to feed the beast, right? An LLM essentially reads a library larger than any human could read in 1,000 lifetimes. But here is the most important part. It's not memorizing the text. Instead, it's learning the statistical relationships between words. It's learning that the capital of France is very likely followed by is Paris. It's learning the patterns, the grammar, and the style of human language.
Step 2 is tokenization. See, a computer can't just read a sentence like we can. It needs to chop it up into smaller, manageable pieces. And these little pieces are called tokens. A token can be a whole word, like love, or just a part of a word, or even a simple punctuation mark, like an exclamation point. This is how you make human language digestible for a machine.
All right, so we've got our tokens, our little pieces of language. Now for the really cool part. Computers run on numbers, not words. So every single token is converted into a long list of numbers called an embedding. You can think of it like giving each word a set of coordinates on a giant, multi-dimensional map of language. And on this map, words with similar meanings like king and queen end up being located very close to each other. This is how the model starts to understand context.
And this brings us to the main event, the transformer. This is the brain of the whole operation. It's a specific type of neural network architecture that Google researchers introduced back in 2017, and it completely changed the game. The transformer is the engine that takes all those numbers, those embeddings, and actually makes sense of them all together.
Now, the secret sauce inside the transformer is a mechanism called self-attention. To understand it, just look at this sentence. The dog chased the ball because it was fast. So what does it refer to? The dog or the ball? For us, that's pretty simple to figure out, but for a computer, that kind of ambiguity is a massive challenge.
And this is what makes self-attention so brilliant. It allows the model to look at the entire sentence all at once, instead of just reading word by word. It weighs the relationships between all the different words and calculates that, in this context, the word fast is statistically much more likely to be connected to dog than to ball. This ability to see the big picture is what allows the AI to generate text that actually feels coherent.
And that brings us to the final step, prediction. After all of that complex processing, the model does something that's actually pretty simple. It just predicts the single most probable next token. It adds that word to the sequence, looks at the new, slightly longer sentence, and then does the whole process over again to predict the next most likely word, and so on, building its response one token at a time.
Okay, so that's the complex machinery running under the hood. But let's bring this all back from theory to your screen. Where are you actually encountering these powerful models out there in the wild?
You've definitely heard these names before.
You've got OpenAI's GPT models, which are the engine behind tools like ChatGPT. Google has BERT, which works behind the scenes in their search engine to better understand what you're actually looking for. Then you've got models like Claude from Anthropic, great for long-form reasoning, and Meta's Llama models, which are huge in the open-source community.
So, with all this technology and all these different models, what can they actually do? What are the real-world applications?
Well, the range is just staggering. We're talking about everything from writing creative stories and marketing emails to powering customer service chatbots to translating languages in real time. They can even write computer code for developers. They're quickly becoming the ultimate Swiss Army knife for anything related to language. But, and this is a really big but, it is not all magic. It's absolutely crucial that we understand the limitations. So let's pivot for a minute and do a quick reality check on what these models can't do. This is probably the single most important question you can ask about this technology. After seeing everything it can do, it's easy to start thinking there's a real mind inside the machine. But does it actually know anything the way you and I do?
The short answer is no. And that leads to a huge problem that people in the industry call hallucinations. Because the model is always just predicting the next most plausible sounding word, it can sometimes just make stuff up. And it will generate text that sounds completely confident and authoritative, but is just factually wrong. It's not lying, it doesn't know that it's wrong, it's just a statistical pattern that went off the rails.
Another critical issue is bias. Remember all that training data from the internet? Well, human beings wrote that stuff. And human writing is absolutely full of our biases, both conscious and unconscious. The model learns from our text, so it inevitably absorbs and can even amplify those biases in its responses. This is a massive area of concern and research.
Which brings us to the bottom line. An LLM has no beliefs. It has no consciousness. It has no genuine understanding of the world. It is a supremely sophisticated pattern-matching machine. It doesn't know why Paris is the capital of France. It only knows that after seeing the phrase, "the capital of France is," billions of times, the word Paris has an extremely high probability of coming next. That's it.
This quote really sums it all up perfectly. It's not about knowing facts. It's about being incredibly good at predicting what sequence of words sounds correct based on all the patterns it's learned. It is a master of linguistic probability, not a master of truth.
And so that leaves us with a final, pretty big question to think about. As these incredibly powerful tools become more and more integrated into our lives, into our search engines, our work, our schools, what happens when our information systems are increasingly powered by technology that prioritizes what sounds right over what is actually true? It's definitely something we all need to consider.